It's important that your students know the 4 types of main movement to learn about mechanisms, pick the right mechanism, and then work out their actual output. This movie will explain linear movement, movement in a straight line.
Movement in one direction. Here you can see a good example of that.
Here we have reciprocating. The needle on this sewing machine is moving in a reciprocating movement.
That's a straight line back and forth movement. The needle on this sewing machine is a good example of reciprocating movement.
Then we have rotary. The hands on this clock or watch are moving in a rotating movement. And finally, the 4th movement is oscillating. This clock shows a good example of oscillating movement.
Swing back and forth movement, like a pendulum on a clock. This particular clock has the tongue that is swinging back and forth.
It's important that your students know what mechanisms are available to them, understand how they work, and then this program will show you how to mark out and make them. Here we have an eccentric cam.
The distance from the centre of your disc will determine the amount of movement you achieve. This one has the shaft hole on the outside, achieving quite a long movement. See how it moves the head of the giraffe up and down.
The images on the right will show an automaton that's used that movement. Here we have 2 eccentric cams that create oscillating movement.
Eccentric cams are being used. You can see the pins that are actually stopping at certain points. The effect we're getting from this is a head that's nodding and saying no.
This concentric cam shows how rotary movement is moved around 90 degrees, and also how ratio changes and also direction.
The position of the cam follow disc over the cam will determine its ratio from the outside 1 to 1, going over to 2 to 1, and then in the middle it will not turn it. Then as you go to the left it changes direction, then it goes back to 1 to 1.
This automaton explains ratio between the input and the output.
When you look at the amount of turns on the input to the output, you have a ratio of about 1 to 3. See the difference in speed of turning the handle to the fish turning.
This shows a snail cam. You can see how this automaton is used, the snail cam.
The automaton of the devil hopping at the top of a coffin uses a snail cam to create that snap action. Slow up and a quick down of the lid of the coffin.
Each of these pages will take you to the section to show you how to mark out and make. We'll go through a few more. This is a very versatile mechanism, and this is a crank. It uses piano wire. Let me show you the movie.
This crank made of 2 discs uses a plastic tube for the collar. Piano wire is also used, so you can actually change the direction from the input to the output. You can see here how the arrow is going backwards and forwards.
This student used this mechanism to create this really interesting automaton frog trying to catch a fly.
Piano wire that gets the tongue of the frog, makes it go in and out.
Here we have one talking about gears. This uses a pulley, but it's drilled off centre, so it works as a crank. It's really interesting. Here we have 2 pulleys. In this case, the main picture shows us a different ratio.
Here we have 2 pulleys, the drive and the driven, a ratio of 2 to 1. You turn the handle, you actually get 2 shafts moving inside your box.
This shows the shaft. The shaft needs to be put in the right position. This movie shows how 2 shafts are being used.
This uses pulley system. So the driven shaft can move an extra shaft to get to that movement.
A collar is really, really important, and without that we're going to struggle to convert your movement from in the box to on top of it.
If you don't use a collar, you try to get the cam to move the follower up and down, it will push the follower sideways and not up and down. But if you put a collar in, like so, the collar will allow that cam to move freely.
Here we have one talking about the follower itself, fulcrums, pivots, levers, etc. Marking out and creating cranks. This shows a ratchet. There's a big section on ratchets. It's important your students then can find out the mechanism they want. They click on the text on the left hand side, or take that part of the program, or for instance, if you look at this Scotch yoke, it's a really interesting mechanism. A piece of acrylic disc has been put in to show you how the inside works.
And it powers on both the up and down stroke.
Lots of other types of movement. A ratchet can be really helpful.
A ratchet ball only goes in one direction. 8 revolutions of the input for 1 revolution of the output. It will only go in one direction because of the ratchet. It's not a smooth action on the output. It's a jerky start and stop action.
Ratchet's a great mechanism when you've got 2 shafts and you want one moving quicker than the other. Here's lots more. A barrel cam is quite an interesting one as well.
Here we have 2 cams working together, creating movement on a lever, which is in an oscillating movement. You can see there's the fulcrum halfway up, and at the top we have a linkage that's moving a saw. This saw is going to be attached to a man.
Hope you found this interesting. Your students can use this program independently and work out their own mechanisms.